Humanoid robots are rapidly advancing at a rate quicker than expected. In this video, I will do a deep dive on the top humanoid robots that exist in 2025. Engine AI is a cutting-edge robotics company based in Shenzhen, China, that has quickly gained recognition in the global robotics industry since its founding in October 2023. The company specializes in developing humanoid robots with lifelike movement capabilities, setting a new benchmark for realism and functionality in robotics technology. Among its creations, Engine AI's SE01 humanoid robot stands out for its remarkably human-like gait and advanced motion control, achieved through the use of NVIDIA's Isaac Gym, a virtual environment that enables sophisticated AI training. This platform allows the robot to simulate and refine movements before implementing them in the physical world, resulting in fluid and natural locomotion that closely mimics human behavior. Engine AI's team, composed of 36 researchers from prestigious institutions such as UC Berkeley, has focused on addressing long-standing challenges in robotics, such as stiff or awkward movement patterns. By combining deep reinforcement learning with imitation learning based on actual human motion, they have created robots capable of performing complex tasks with agility and precision. For example, the SE01 robot can squat, run, do push-ups, and even handle industrial tasks like heavy lifting or precise assembly on factory lines. Additionally, Engine AI's PM01 model has demonstrated impressive feats of agility, including performing front flips, a significant achievement given the difficulty of maintaining balance during such maneuvers. The company offers a diverse product lineup tailored to various applications. The SE01 is designed for industrial use, while the SA01 serves educational purposes, and the PM01 focuses on agile performance. These robots are not only functional, but also open source platforms, allowing researchers and developers to customize their firmware and hardware for specific needs. This openness accelerates innovation in robotics by enabling collaborative improvements across academic and industrial communities. Engine AI's advancements are reshaping perceptions of humanoid robots by bridging the gap between mechanical functionality and human-like grace. Their robots are being tested in real-world scenarios, such as assisting law enforcement and interacting with the public. The company's rapid progress highlights China's growing influence in AI and robotics innovation, positioning Engine AI as a leader in this competitive field. By aiming to mass-produce thousands of humanoid robots by the end of 2025, Engine AI is pushing the boundaries of embodied intelligence and redefining what is possible for humanoid machines in industries ranging from manufacturing to education and public service. Next, let's take a look at the Figure robot. The Figure 02 is a cutting-edge humanoid robot developed by Figure AI, representing a significant advancement in the field of robotics and artificial intelligence. Standing at 5'6" tall with a payload capacity of 20 kilograms, the Figure 02 is designed to closely mimic human form and function, making it ideal for performing a wide range of tasks in environments built for people. This second-generation humanoid robot boasts impressive features that set it apart from its predecessors and competitors. The Figure 02 is powered by an electric system that allows it to operate for up to 5 hours on a single charge, with a custom battery pack integrated into its torso, providing 50% more energy than its previous iteration. The robot's mobility is enhanced by its ability to move at speeds of up to 1.2 meters per second and navigate complex environments with ease. One of the most striking aspects of the Figure 02 is its advanced AI capabilities, which enable it to perceive and understand its surroundings, adapt to changing conditions, and even engage in speech-to-speech conversations with humans. The robot's onboard vision language model, powered by 6 RGB cameras, allows for fast, common-sense visual reasoning, while its partnership with OpenAI has led to the development of custom AI models that drive its conversational abilities. The Figure 02's dexterity is another standout feature, with its 4th-generation hands equipped with 16 degrees of freedom per hand, mimicking the strength and agility of human hands. This level of dexterity allows the robot to perform intricate tasks with precision, from manipulating delicate objects to operating tools and machinery. Recent demonstrations of the Figure 02's capabilities have showcased its potential in both industrial and domestic settings. In a notable demonstration, 2 Figure 02 robots were shown working collaboratively to put away groceries in a kitchen environment. The robots demonstrated an impressive ability to reason about where items should be placed, even when encountering objects they had never seen before. This task required complex decision-making, spatial awareness, and fine motor control, all of which the Figure 02 executed with apparent ease. The robots were able to open and close drawers and refrigerator doors, place items in appropriate locations, and even hand off items to each other when necessary. Another demonstration highlighted the Figure 02's potential in industrial applications, showing multiple robots working together to sort packages on an assembly line. This demo emphasized the robot's ability to handle unfamiliar objects, orient them correctly, and even correct their own mistakes, all crucial skills for real-world manufacturing and logistics operations. What makes these demonstrations particularly impressive is the use of Figure's Helix AI, a vision language action model that allows the robots to operate autonomously based on simple verbal commands. The fact that multiple robots can work together seamlessly, sharing a single set of neural network weights, points to the scalability and flexibility of the system. Figure AI has also made significant strides in bringing the Figure 02 closer to real-world applications. The company has already conducted tests with BMW Group using the robot on a production line for handling fitted sheet metal parts. This real-world trial, along with the announcement that Figure AI has delivered Figure 02 robots to a paying customer, marks an important milestone in the commercialization of humanoid robots. The rapid development of the Figure 02, from the company's founding in 2022 to its current capabilities, demonstrates the potential for humanoid robots to address labor shortages and improve efficiency across various industries. As Figure AI continues to refine and expand the capabilities of the Figure 02, it is poised to play a significant role in shaping the future of work and human-robot interaction. Next, let's take a look at the Boston Dynamics Atlas robot. The Boston Dynamics Atlas is a cutting-edge humanoid robot that has become an icon in the robotics industry since its initial unveiling in 2013. Standing at 1.5 meters tall and weighing 89 kilograms, Atlas is designed with an emphasis on advanced mobility, dexterity, and a high strength-to-weight ratio. The robot incorporates titanium and aluminum materials with extensive use of 3D printing technology to optimize its frame for both robustness and relatively low weight. What makes Atlas truly remarkable is its impressive agility and physical capabilities, which have continually evolved over the years. The robot has transitioned from a partially hydraulic machine to a fully electrified robot, marking a significant advancement in its efficiency and flexibility. Atlas is equipped with 28 joints and advanced control algorithms that enable it to execute tasks with high precision while adapting to its environment. Its design allows for 360-degree swiveling capability at the hips, waist, arms, and neck, giving it unique movement options that human bodies cannot replicate. In January 2025, Boston Dynamics announced a major milestone for Atlas: complete autonomy. The robot can now function entirely on its own, without pre-programmed sequences or remote control, making decisions and generating actions in real time. This autonomous functionality represents a significant leap in humanoid robotics, allowing Atlas to handle tasks requiring not only dexterity, but also decision-making based on its immediate surroundings. Boston Dynamics has recently showcased Atlas's capabilities through several impressive demonstrations. In March 2025, they released footage showing Atlas performing a variety of complex movements that appear remarkably human-like. The demonstration began with Atlas walking and running with natural motion, leaning forward as it starts running and pulling its torso back when slowing down, showing a real sense of balance. The robot then progressed to more complex movements, including cartwheels, handstands, and even breakdancing. These fluid movements were developed using reinforcement learning techniques combined with motion capture data from human performers. Rather than following rigid programming, Atlas now learns through trial and error, adapting to its environment and improving its responses continuously. This approach allows the robot to recover from stumbles, make sharp pivots, and maintain balance through quick adjustments. Boston Dynamics has also been collaborating with NVIDIA to enhance Atlas's capabilities further. Atlas now runs on NVIDIA's Jetson Thor computing platform, which allows it to process complex multimodal AI models in real time. This partnership aims to advance AI capabilities in humanoid robots, with Atlas being an early adopter of NVIDIA's Isaac GR00T platform. The collaboration focuses on defining parameters for functional safety and security architecture, as well as key learning and computer vision pipelines. Beyond impressive demonstrations of agility and power, Atlas has practical applications in various fields. Boston Dynamics is working with its parent company Hyundai to train Atlas for factory work, specifically part sequencing in automotive manufacturing. This task involves sorting thousands of different parts with varying shapes, weights, and sizes, a complex challenge requiring recognition of mistakes, correction, and learning of edge cases without constant human intervention. The robot's potential extends to disaster recovery, search and rescue operations, and handling logistics in environments too dangerous for humans. With its continuous advancements in both hardware and software, Atlas represents the cutting edge of what's possible in humanoid robotics, bringing us closer to a future where robots can assist in complex and unpredictable environments. Now let's take a look at the recent advancement and humanoid robot NeoGamma. NeoGamma is an advanced humanoid robot developed by Norwegian company 1X Technologies, designed specifically as a home assistant capable of performing household chores and interacting naturally with humans. What makes NeoGamma particularly remarkable is its unique design approach that prioritizes human comfort and home integration. Unlike conventional humanoid robots with rigid mechanical appearances, NeoGamma features a soft knitted nylon bodysuit created using a Japanese shimaseki machine, giving it a more approachable, clothed look that helps it blend seamlessly into home environments. This soft exterior not only makes the robot more aesthetically pleasing, but also serves a practical purpose by preventing it from damaging fragile objects and reducing potential injuries from robot to human contact. The robot features distinctive emotive earrings that light up when it listens to owners and provide visual feedback about its status, enhancing the intuitive interaction experience. NeoGamma's movement capabilities are particularly impressive, as it can walk with a natural human gait, including coordinated arm swings, squat to pick up objects from the floor, sit in chairs, and handle various household items with precision. These movements are powered by a multi-purpose whole-body controller running at 100 Hz that uses reinforcement learning based on human motion capture data. The robot is equipped with advanced AI systems, including an in-house developed language model that enables natural conversations without requiring button presses, making interactions feel more human-like. For audio capabilities, NeoGamma features 4 strategically placed microphones with beamforming and echo cancellation for clear audio capture, along with a 3-speaker system, 1 in the chest for AI voice interactions, and 2 in the pelvis area for bass and 360-degree sound effects. In recent demos, 1X has showcased NeoGamma performing various household tasks. During a presentation at NVIDIA GTC 2025, the robot demonstrated abilities such as vacuuming, watering plants, and navigating around a living room setting without bumping into people or furniture, though the demo wasn't flawless as the robot experienced some issues attributed to spotty Wi-Fi and low battery. Other demonstration videos have shown NeoGamma carrying a kettle of hot water, straightening pictures, carrying laundry, cleaning windows, picking up grocery bags, delivering wine, and tidying up spaces. While these capabilities are impressive, it's worth noting that NeoGamma is not yet fully autonomous in its current state. For the upcoming home test planned for later in 2025, 1X will be bootstrapping the process by relying on teleoperators, humans in remote locations who can view the robot's cameras and sensors in real time and take control of its limbs when needed. The company has announced plans to begin testing NeoGamma in a few hundred to a few thousand homes by the end of 2025, with CEO Bernd Bernick explaining that these tests will help the company develop the system by allowing it to live and learn among people. This approach will enable 1X to collect valuable data on how the robot operates in real home environments, creating a dataset that can be used to train AI models and upgrade NeoGamma's capabilities over time. Now let's take a look at another company coming out of London. The HMD-01 is a next-generation humanoid robot developed by Humanoid, a London-based AI and robotics startup founded in 2024 by serial entrepreneur Artem Sokolov. Standing 175 centimeters tall and weighing 70 kilograms, this general-purpose humanoid robot represents a significant advancement in robotics technology designed to address labor shortages and enhance automation across various industries. The HMD-01 boasts impressive specifications, including a walking speed of 3.3 miles per hour, an average runtime of 4 hours, and a payload capacity of 15 kilograms. What makes this robot particularly exceptional is its modular design concept, allowing customers to incorporate different upper body, lower body, and end effector configurations to ensure adaptability, better meet specific requirements, and reduce costs. This modularity extends to both hardware and software, with the robot featuring interchangeable protective garments that safeguard its internal systems and the surrounding environment. The HMD-01's perception system combines multiple sensor technologies, including RGBD cameras for high-resolution object recognition, LiDAR sensors with a 40-meter range for navigation, and tactile sensors with over 1,000 pressure points in the hands for precise manipulation. These sensors merge data at 60 Hz to create a realistic environmental map, enabling the robot to track up to 300 inventory items simultaneously while safely navigating around human workers. The robot's AI integration is equally impressive, with an object detection system trained on extensive synthetic datasets achieving 98.7% recognition accuracy in pick-and-place tasks, exceeding the average human worker accuracy of 95.4%. The HMND-01's hierarchical task planner can break down complex instructions into executable steps and adapt to changing conditions, successfully navigating around 83% of unexpected obstacles in retail simulations. The robot is designed for industrial applications such as goods handling, picking and packing, kitting, and part handling, with potential to enhance automation levels in retail and manufacturing facilities, logistics and fulfillment centers, and warehouses. Humanoid's vision is to create a future where humans and machines work side by side harmoniously, addressing workforce shortages and aging population issues while freeing people to focus on more creative and meaningful work. The company plans to develop and test alpha prototypes for both wheeled and bipedal platforms in 2025, with ongoing discussions with leading retail companies for potential pilot projects. With the global humanoid robotics market predicted to grow at a compound annual rate of 95% from 2022 to 2030, reaching $6.5 billion by decade's end, the HMND-01 represents a significant step toward a future where humanoid robots become an integral part of the global economy. Now let's take a look at a robot coming out of China. The Unitree G1 is a groundbreaking humanoid robot that has significantly advanced the field of robotics with its exceptional mobility, dexterity, and affordability. Standing at 1.32 meters tall and weighing approximately 35 kilograms, the G1 was introduced as a mass production version in August 2024 by Chinese company Unitree Robotics. What makes the G1 particularly remarkable is its price point of just $16,000, making it one of the most accessible humanoid robots on the market and positioning it to compete with industry giants like Boston Dynamics and Tesla. The G1's design incorporates 23 degrees of freedom in its joints, with some models featuring up to 43 degrees of freedom, enabling it to perform complex movements with impressive precision. This exceptional joint flexibility allows the robot to execute intricate maneuvers such as jumping, spinning, climbing stairs, and even performing martial arts techniques. The robot is equipped with advanced sensors, including an Intel RealSense D435 depth camera and a Livox MID 360 LiDAR puck, providing it with 360-degree environmental awareness for precise navigation and obstacle avoidance. For power, the G1 uses a 9,000 mAh lithium-ion battery that provides approximately 2 hours of operation per charge and features a quick release mechanism for easy battery swaps during extended use. In terms of recent advancements, Unitree has been continuously improving the G1's algorithm, allowing it to achieve increasingly impressive feats. In early 2025, the G1 demonstrated enhanced walking and running capabilities, with the company claiming it now has the smoothest walking and running of any humanoid robot in the world. By February 2025, Unitree introduced a new algorithm update that enables the G1 to learn and perform dance routines with human-like precision and fluidity using an open-source full-body motion dataset captured with advanced motion control technology. The robot begins training in NVIDIA's Isaac simulator, where it observes human movements through motion, video data, and reinforcement learning before transferring these skills to the physical robot through a process called Sim to Real. March 2025 brought even more impressive demonstrations, with videos showing the G1 performing kung fu techniques, including spinning kicks, and most recently executing a standing side flip and a kip-up maneuver, showcasing its exceptional balance, coordination, and precision. These achievements highlight the rapid advancement in the robot's capabilities, with new updates being released monthly. The G1's practical applications span numerous industries, from manufacturing and automation to research and entertainment. In industrial settings, it can handle repetitive tasks with speed and accuracy, navigate tight spaces for transporting goods, and perform quality control with its advanced vision system. For AI research and development, the G1 serves as a powerful tool for machine learning training, allowing engineers to program it to analyze data, adapt to new tasks, and refine its decision-making skills. The robot's exceptional mobility and resilience also make it valuable for disaster response and emergency situations, where it can navigate rubble, assess damage, and assist in search and rescue operations. With its combination of affordability, advanced capabilities, and continuous improvements, the Unitree G1 represents a significant step forward in making sophisticated humanoid robots accessible for various applications, potentially democratizing access to advanced robotics across industries and accelerating innovation in the field. Now let's take a look at a humanoid robot that is taking an entirely different approach. Clone Robotics has developed the ProtoClone WEAP1, a groundbreaking humanoid robot that represents a significant advancement in biomimetic robotics. Unveiled in February 2025, this faceless, anatomically accurate synthetic human stands at 6 feet tall and features over 200 degrees of freedom, more than 1,000 myofibers, artificial muscles, and over 500 sensors. What makes the ProtoClone truly revolutionary is its biomimetic design that closely replicates human anatomy. Unlike traditional robots that use motors and gears, the ProtoClone features a polymer skeleton with 206 synthetic bones connected by artificial ligaments and tendons, mimicking the complete human skeletal structure. The robot's movement is powered by Clone's proprietary myofiber technology, developed in 2021, which consists of water-powered artificial muscles made of mesh tubes containing balloons that contract when filled with hydraulic fluid. These muscles can contract 30% faster than human muscles and have a response time under 50 milliseconds, providing human-like strength even in the fingers. The muscular system is powered by a 500-watt electric pump that serves as the robot's heart, circulating fluid at 40 liters per minute and also functioning as a cooling system similar to human sweating. The ProtoClone's nervous system is equally impressive, equipped with 4 depth cameras in its skull that serve as eyes, 70 inertial sensors to trace joint positions, and 320 pressure sensors to assess the strength needed for various tasks. All of these are integrated with NVIDIA's Jetson Thor GPU for real-time processing one. Recent demonstrations show the ProtoClone suspended from the ceiling, displaying eerily lifelike movements that blur the line between machine and human. While still in development and requiring external support for stability due to challenges with real-time balance adjustments, the robot has already showcased impressive capabilities. Clone Robotics envisions the ProtoClone performing a variety of tasks including household chores like doing laundry, washing dishes, cooking basic meals, and even engaging in witty dialogue. The company plans to release 279 units of the limited edition Clone Alpha in 2025, with a price tag of approximately $20,000. Founded in 2021 by Danush Radhakrishna and Polish engineer Łukasz Kozlik, Clone Robotics has attracted significant investment, including $640,000 from angel investors and venture capitalists, such as the co-founder of Y Combinator and former CTO of Coinbase. The company's ultimate goal is to create synthetic humans capable of long-term independent operation in complex settings, potentially revolutionizing industries ranging from household assistance to healthcare, manufacturing, and customer service. While the ProtoClone has sparked both fascination and unease due to its unsettlingly lifelike movements and faceless design, it represents a major shift in robotics that could redefine the industry's approach to biomimetic engineering. Now let's take a look at Elon Musk's humanoid robot. The Tesla bot, also known as Optimus, is a humanoid robot designed by Tesla to perform tasks that are repetitive, dangerous, or undesirable for humans. Standing at approximately 170 centimeters tall and weighing around 60 to 73 kilograms, it's built to closely resemble human proportions and capabilities. The robot was first announced at Tesla's AI Day event in August 2021, with Elon Musk describing it as a general-purpose robotic assistant that could eventually become more significant than Tesla's vehicle business. What makes the Tesla bot particularly impressive is its integration of Tesla's existing automotive technology. It uses the same AI systems, batteries, power electronics, advanced motors, and full self-driving computer that power Tesla vehicles, essentially functioning as a robot with arms and legs instead of a robot with wheels. The robot features 40 electromechanical actuators distributed throughout its body, allowing for complex movements and tasks. It has a carrying capacity of 20 kilograms, can lift up to 68 kilograms, and can move at speeds up to 8 kilometers per hour. The Tesla bot is equipped with advanced sensory capabilities, including vision sensors, audio sensors, movement sensors, and touch force sensors that enable it to perceive and interact with its environment. Recent advancements in the Tesla bot have been substantial. Tesla unveiled Optimus Gen 2 in December 2023, which showed significant improvements over the first prototype from 2022. In March 2025, Elon Musk announced plans for Optimus Gen 3, which is expected to feature upgraded hands with double the degrees of freedom, improved water resistance, faster mobility, and a more natural gait seat. Recent demonstrations have showcased the robot's ability to adapt to new environments, perform precision tasks like sorting blocks, maintain balance, even standing on one leg, and navigate uneven terrain autonomously. In December 2024, Tesla shared a video showing Optimus traversing uneven terrain and catching itself when slipping, all without using vision, instead relying solely on its neural network and sensors. Tesla is rapidly scaling up production of these robots. During an all-hands meeting in March 2025, Musk told employees that Tesla plans to build 5,000 Optimus units in 2025, with components available for 10,000 to 12,000 units, and aims to scale to 50,000 robots by 2026. Musk has repeatedly stated that the price point for Optimus will be around $20,000 or possibly lower, making it accessible for widespread adoption. 3. The robot is expected to be capable of performing thousands of different tasks, from household chores like washing dishes, cooking, and cleaning to more complex industrial applications. Musk envisions Optimus as potentially the biggest product ever of any kind that could lead to an age of abundance where physical work becomes a choice rather than a necessity. The Tesla bot represents a convergence of AI, robotics, and energy innovations that could revolutionize how we approach labor-intensive tasks across manufacturing, logistics, healthcare, and home environments.